I'm the founder and CEO of Reva Projects. We are a design studio and a manufacturer for emergency shelters for natural disasters. We're developing a portfolio of emergency shelters for extreme climate conditions. Behind me, you'll see our prototype for the cold climate shelter, which was designed to Switzerland standards of construction and building codes. It can withstand 160 mile-per-hour wind, massive snow loads. It's modular, it's lightweight aluminum, and it's insulated to withstand a negative 30 degrees Celsius temperature. When disaster hits, we have to react fast. The first few days are very important, and this is why we believe that through a group of volunteers, we can store these shelters on site and we can work with local jurisdictions and official agencies to help deploy them rapidly. Our idea was born in 2012 when Hurricane Sandy hit New York City, and the best evacuation was a shared space. So we would like to offer a private space for the victims to have a place to cope, to provide dignity, and just a better quality space to share with their family to cope. Currently in Ukraine, there is such a big need for emergency shelters for all the refugees all over the world, not just Ukraine. And we believe that something that could be rapidly deployed, flat packed, and easily moved is the solution for current conflicts. And it can really relieve the economic weight on the local governments on how to find solutions for the victims of all kinds of disasters.
Hi, my name is Mike Zahender and I work for Reva Projects. Today we're discussing the power panel, the heating element, and the other configuration pieces of the Reva cold winter shelter. This is a 60 amp power supply panel that has all the power inputs into it to allow it to be distributed. We have multiple 220 outlets and multiple GFCI protected 120 volt outlets. And these provide all the power that's necessary here. We also have configurations where we work with 50 hertz and 280 volts so that we can have any type of international power supply used. So the power comes in from the outside of the shelter and plugs into a standard plug. We can use any standard plug provided by the customer or outlet. This is all IP65 and it's usually mounted on the outside of the shelter and it's able to take the rain, the weather, or whatever may come. On the inside of the power panel, you can see you have individual breakers as well as a main power shutoff. This is necessary for code in most parts of North America. Over here, we see the Bromic tungsten smart heater. This 4,000 watt heater supplies enough heat to heat the entire shelter even when temperatures dip below -10. The reason why is because of the insulation. So this is controlled in a central place, not with a wireless controller, but with a physical controller, so you'd have fewer failure points. Additionally, we have air conditioning units as a separate configuration that have inlet and outlet ports on the side of the shelter. A single 3-ton air conditioner can actually keep the shelter cool in a 100-degree F environment. We run our power on the side of the shelter in a single power channel so that all 110 power and 120 power exists in one side. On the other side of the shelter, where we have sleeping areas, we run USB power so individuals can power and recharge their USB equipment.
As we step inside, you can see that the structure is modular. It's constructed out of lightweight aluminum, so it can be handled by hand. So the entire structure can be assembled by 2 people by hand with no tools under 3 hours. And this was our original goal from the beginning. So here you're seeing a 3-module structure. This could be as little as a 2-module structure and as large as a 5-module structure on an average ground level. If you have a straight floor, you can have an infinite number of modules, of course, to grow. Each module is composed of 7 submodules. So we have submodule 1, 2, 3, 4, 5, 6, 7. So each submodule is connected with a quick release pin that could be taken out and snapped in place quickly. And this allows us to assemble each module in minutes. After each module is assembled, it's tilted upright and then they're connected to each other. The floor is a sandwiched vacuum insulation panels which have a value of insulation of R50. We believe our floor is the most important part in this design in order to insulate the space. So vacuum insulation panel is gas filled and it's sandwiched between two aluminum plates, and it has plastic engineered siding around. Once the floor is put in, then we begin with the cover. Our wall construction has a rating of R20, and it's put together with a super quilt UK-based insulation, which is layered foil, combination with an air gap and a marine grade Search Ferrari vinyl cover, which is the waterproof membrane of this wall construction. We have different options for our exterior covers. Search Ferrari vinyl is our standard option. We also offer an antibacterial cover for medical use. And the other option is a ballistic proof cover made in South Korea. The interior insulation will have a lighting, LED lighting sewn into the edges and the zippers, which will go in, as you can see here, on the frames, the vertical frames of the structure. So we have two types of windows. We have side windows, which are translucent but not transparent, that allow privacy for the users of the shelter. Our custom designed windows are designed to be assembled by hand with no tools using these easy twist fasteners, and they have a special gap underneath so you can tuck in the insulation and outside vinyl for a waterproof connection.
My role in the company is logistics. After 24 years in the United States Navy as a logistician and emergency manager, I'm confident that this shelter can be flat packed, shipped to the customer, and be able to put up by any individual with just a ladder. Toolless assembly is key on this shelter. I can set it up. Just about anybody can set it up.
Our design studio is based in New Jersey, but our manufacturing distribution comes from Wisconsin, United States. We source all of our materials from NATO countries. Our company is global. Our team consists of designers and architects from all over the world. This particular shelter was designed by Max Borszewski, who specializes in cold climate condition construction. We also work with structural engineers, mechanical, industrial, geotechnical, and all kinds of emergency response specialists who advise us throughout the process of development of our design.